Hi guys, this is Chapter 11, Lesson 5 on appropriate measure. Good news is that this is the last lesson for this chapter. You're going to need your math book and have it out and open to pages 845 through 848, and you need a pencil and a pen. So, what we're going to be learning in this section is we're going to learn why a measure of center might not be appropriate. Now remember, measures of center have to do with mean, median, and mode. And we're also going to learn how to choose the appropriate measure of center, especially when certain ones are not good. All right, so let's look at this bottom part right here. So what I want you guys to do here is, it says the Green Committee had a recycling drive where they collected aluminum cans, plastic bottles, newspapers, and batteries. The weights collected on the first day are shown, so you can see the pictures and where they put all the weights down. So question number 1 says for you to find the mean weight collected. So go ahead and pause your video now to find the mean for the weights that have been collected on that first day. So those are those numbers that you have to add together and then divide by 4. Pause now. So you can see here I'm adding my numbers. I end up getting 55.7 total pounds. Then I'm going to divide it by 4. And I end up getting 13.925 pounds. And I'm going to go ahead and write that down on my first line. Now, question number 2 says, if the newspapers are not included, find the mean weight to the nearest hundredth. Okay, so what that means is they want us to find the mean again, except this time they want us to find it without the newspapers. So instead of adding those 3 numbers again, the 12.2, the 11, and the 13, I already know when I added all 4 of them together, I got 55.7. So I'm just going to take my 55.7 and subtract the 19.5 from it because that's the weight of my newspapers. Then I'm going to go ahead and divide it by 3. So you'll notice here on this one, you're going to end up getting a repeating decimal. But since it's said to round it to the nearest hundredth, 12.066666 ends up rounding to 12.07. So we're going to write that on the line. Pounds. All right. So question number 3 asks, how does the weight of the newspapers affect the mean? You guys, when you're asked to, like, how does something affect it, look at the 2 numbers that you have here, and we're going to compare them. So the 2 numbers that I'm talking about are the number that we got from question number 1 and the number that we got from question number 2. So compare them. If you look at question number 1, 13.925 pounds is really close to about 14 pounds. And 12.07 pounds is really close to 12 pounds. So if you want to figure out how it affects it, I would just subtract them. So how does it affect it? Well, it causes the mean to be about 2 pounds higher. So that's how the newspapers affect it. And then question number 4 asks, what is the median for the data set? Now remember, in order to find the median, you have to put your numbers in order from least to greatest. Now when you do this, you're going to find that you have 2 middle numbers. So you have to find the mean of the 2 middle numbers. You're going to end up getting 12.6 for the median. And the way that it affects the, how does the median differ if the newspapers are not included? That means you're going to do it again. And this time you're going to find the median without the newspapers. And then you're going to compare them, which means you would subtract them again. And it ends up being 0.4 of a pound less. Okay. So this is the part that's going to tell us what to do. Now, what we're doing here is a lot of times you're going to notice that if you are asked to find mean or sometimes median or mode, depending on outliers, yes, I know those outliers, but depending on a certain set of numbers, sometimes mean is not the appropriate thing to use, like it's not the best one to use. Sometimes median is not the best one to use, and sometimes mode is not the best one to use, especially when outliers come into play. We're not going to do that for another page. So what you want to think about is this, and this is really important to know. That's why I wrote this on the top of the page, which you might want to write down on here. Put a big star and say, learn me, know me. So it says here, The time when you want to use mean, that means you add them up and divide by however many digits that you had or numbers that you had, is when you have no extreme values. What that means is you don't have, basically we're talking mainly about outliers, numbers that are so far away from most of the other numbers that you have. Because when you include them in there, then it's going to end up throwing your average off. Now, for median, when it's appropriate to use median, which remembers your middle number, that's when your information, your data does have extreme values, because sometimes if you've got a number way, way, way off to the side, it's not going to really affect it a whole lot as far as like what your middle number is going to be. However, it's also important to know that there cannot be any huge or big gaps in the middle of the data. So you want to make sure, like in your middle data, you don't have like numbers like 13, 15, 17, 95, 97, and 93, because then there's a big gap there and that's not going to help you. And then sometimes it's most appropriate to use mode when your data is repeated several times. And it's going to make more sense as we go through the next few examples. Okay, so let's look at example 1. Example 1 says the table shows the number of medals won by the U.S. Which measure of center best represents the data? So that's the first thing we're going to have to do, is determine which measure of center we're going to use, whether it's mean, median, or mode, using the information from the previous screen, which is at the top of your paper that you're looking at. But then we have to actually find the measure of center. All right, so what we're going to do here is we're going to look at the number of medals that were won. So we're looking at these numbers here. So you'll notice that we have 112, 101, 97, 103, and 110. The good thing is that most of these numbers are really close together. And think about the smallest number is 97 and the largest number is 112. Even though they're not that far away from each other. They're about, 12, 15 numbers away from each other, which is really awesome. So basically, because they're not far away from each other, there's no outliers or no like extreme measures, the best measure that we would use would be mean, and they wrote that here. So then you would find the mean, and we don't have to do this because they did this part for us, but you see how they added up all the numbers and divided by 5 and found that the mean number of medals won was or is 104 3/5 medals. Now remember what the mean does, it gives you like a one number summary of this information over here. So I know it's kind of weird to think of summaries in math, but basically that's what measures of center do, is they give you a one number summary of most of the information that you have. All right, so then, we already talked about that part. All right, so let's go to the next one. So the next one here, the table shows the water temperature over several days. Which measure of center best represents the data? Then find the measure of center. Now go ahead and look at your data where it says water temperatures in degrees Fahrenheit. Well, notice how I put a box around all those 82s. So it seems like this has a mode of 82. So because of that, and if you look back at the top of your page, notice where it says mode, you want to use it when you have more than one number. So in the set of data, there are no extreme values. Okay, so we want to rule that out. So that means there's no numbers that are way, way far away from the other numbers. There is a temperature that's repeated 4 times. That's 82. So therefore, mode is the best center of measure. Now, the cool thing about this one is when it's mode, you already found that it was the mode 82, so you don't have to do any additional work other than label mode and tell me what it is, which was 82 degrees on this one. Okay, bummer. Now it's your turn to give this a try. All right, it's not as bad as it looks. So if you look at example A, you're going to go ahead and read this through, and you're going to answer which measure of center best represents the data. So you have to tell me whether it's going to be mean, median, and mode. It does tell you to justify your selection. So this is a sentence that you have to put to tell me why you chose that. So think about the top of your page and go through the motions. Go through and say, well, are there extreme values? And if you say yes, then you know what you need to use. If you say no, then move on to the next one. And that's how you justify your selection. All right, pause now, figure it out, and come up with a sentence and your final answer. So here we go. Since there are no extreme measures or values, There is one number that is repeated 3 times. So therefore, because it's repeated 3 times, the mode is the best measure of center for this. Now, don't forget to tell me what it is. It is $21.95. So this one wasn't too bad. At least you didn't have to sit there and find the mean and all that. All right, next. Now we're going to talk about the same stuff with outliers. So we're still going to find the best measure of center. We're going to find the best measure of center. So it could be mean, median, or mode, except now we're going to talk about how the outliers affect it. And we've talked about outliers. I know you guys just love outliers, especially when you have to sit there and find the IQR and then multiply by 1.5 and all that extra business. All right, so let's look at example 3, 4, and 5 all have to do with the same question. So let's look at the first part. The table shows average lifespans of some animals. So if you look at the table, it gives you anywhere from elephants all the way down to horses. Oh my goodness, those tortoises live for 200 years. All right, so it says here to identify the outlier in the data set. Now it's pretty obvious that 200 is the outlier, but like we talked about in class, that 1,121 from that previous lesson absolutely killed me, so let's double check this. So what you're going to have to do on this one is, so you have to remember, in order to find the outlier, you have to find your IQR, multiply by 1.5, and then you're going to subtract the subtract quartile 1 from it, and then you're going to add quartile 3 to it. So they did this part for you right over here. So I just love it when they do have the work for you. Oh, that was a horrible, horrible heart. A little better. Still bad. Anyways, so they've done that for us. So we realize that the where our range is here is 60 and 130. So therefore, if you're looking at your numbers, 200 falls way beyond those limits. So therefore, we just identified that 200 is an outlier. Okay, so number 4, you see that there's notes here off to the left of these numbers. Yes, you need to put those notes down. So you might want to pause the video so you're listening to me when I come back to talk to you about it, if you haven't already done that. Okay, so with number 4, it says, determine how the outlier affects the mean, median, and mode of the data. Well, the only way you can figure this out, you guys, is if you find mean, median, mode with the outlier, and if you find mean, median, mode without the outlier, just like we did at the very beginning of this lesson with that newspaper example. So you'll see that they've done this for us. So they found the mean with the outlier. Notice how they have it labeled. When you're doing these on your own, you have to label with the outlier and then again label without the outlier. So this way, especially me, when I'm looking at your work, I know what's what and you know what's what when you're going over it the following day. So with the outlier, we found the mean to be 62, the median to be 35, and the mode to be 30. Now, without the outlier, we found the mean to be 39, the median to be 32.5, and the mode to be 30. So the big thing here is the biggest effect that this had was the mean. So you'll notice that most definitely for this type of information, you would not want to use the mean to represent the average lifespans for most of these animals. Yes, that tortoise lives for 200 years. My goodness, who wants to live that long? But it doesn't really represent, 62 right over here, does not really represent the average lifespan of the majority of those animals compared to the 39. So you want to always keep that in mind. All right, so now look at this part right here. We're going to put a little bubble around it because remember your directions ask you to determine how it affects it. So let's talk about this. The mean lifespan decreased by 62 minus 39 or 23 years. So we're comparing the mean on both numbers. So when you're comparing the numbers, tell me how they differ. All right, so just subtract them. So you're going to say that the mean lifespan, and they got the word lifespan from our table up there because it is the lifespan of those animals. So then it goes on to talk about the medians, compare the medians. Well, they're pretty close. The medians decreased because they went down only by 2.5 years, 2.5. The mode did not change. So notice that when you're comparing these guys, you're going to tell me about the mean, you're going to tell me about the median, and then you're going to tell me about the mode. And when you're doing these, most times what you're going to do is you're going to end up just subtracting them find out how they differ. All right, so the next part. Now, question number 5 still has to do with questions 3 and 4. So what I did was I went ahead and on the previous screen, we have this information so we can kind of refer to it, mainly so I can refer to it while we're talking about number 5. So number 5 is your final question. It says, which measure of center best describes the data with and without the outlier? Okay. And then justify your selection. So now it tells us here, first we're going to basically go through and talk about all 3 of them. Let's talk about the mean. The one that was affected the most was the mean, because remember, we had 62 compared to 39. So the outlier affected the mean the most. So they wrote that. The mean was affected the most with the outlier. So tell me about that. Okay. Then it says the median. So that's the next number that we have here. The median lifespan changed very little, which really it did, 2.5 years. With and without the outlier, so it didn't have that much of an effect. So it best describes the data in both cases. So you could use the median to best describe the data for both cases. The mode, however, does not describe the data very well since there were only 2 repeated numbers. Okay, so you want to make sure that when you do use mode to represent a set of numbers, especially a set of numbers that, has about, 8 or so animals. I don't remember how many they had here, 1, 2, 7 animals. You want to make sure if you're going to use a mode, remember mode is the number that shows up the most often. If you're going to use mode to represent your data, it has to show up more than just 2 times. It needs to show up several times, like 3, maybe 4 times, or close to half the number in order for you to say that, hey, mode is the best one. So hopefully that makes sense. All right. Now it's your turn to give this a try again. So now here you've got the prices of some new athletic shoes that are shown in the table. Ooh, those are pretty cheap shoes, for decent athletic shoes, that is. And so what you're going to do is you're going to identify the outlier in the data set. And let me check my nifty answer key here. There is definitely an outlier in there, and I'm going to help you guys out just an itty bitty bit and tell you that the outlier is, can you guess? Hopefully you guessed this one right here. So that guy is going to be your outlier right there. So I'm saving you just a little bit of work on that one. 78.95. Yep. So this way you don't have to sit there and do the whole 1.5 and all that stuff. But the rest, it's all up to you guys. All right, go ahead and pause your video and work this guy out. All right. So the first thing I did is I went ahead and found my mean, median, and mode with the outlier and without the outlier. So I went ahead and just listed them here. So you guys, somewhere on your paper, you need to show me that you've done the work for this. You can't just have it listed like I did. And then I went ahead and worked on Part C. Now, Part C says determine how the outlier affects the mean, median, mode of the data. So I'm going to start with mean and compare them. Remember on our previous page, when we compared them, we basically subtracted them. So that's what I did. I found that they had a difference of $4.44. So the mean decreased $4.44 without the outlier. Then I talked about the median. Well, we had $48.50 with the outlier, $48 without the outlier, so therefore it decreased by only 50 cents, and there was no mode. So for either one. Now, Part D says, tell which measure of center best describes the data with and without the outlier. Well, obviously, since there's no mode, that's completely out of the picture. So we don't even consider that. So we want to pick the one that has the least change. Now, even though the difference in the mean was not that big, $4.44 is not a major difference, but look at it for mean. It was only a 50-cent difference. So we want to make sure we pay attention to that. But you have to tell me what was affected the most. So the mean price was affected the most with the outlier. So because of that, then the median price changed very little with and without the outlier being included in there. So it is the best to describe the data set. So be sure that with your pens to make any corrections that you have. on your papers and make sure that you completely understand on how we're doing this. And of course, we'll go over some more in class. All right, you guys, now it's your turn. You are to complete questions 1 and 2. Now for question 1, I want you to do all 3 parts, A, B, and C. It does ask you to find the outlier of the data set on this one, so you are going to have to do the, interquartile range times 1.5 to figure it out. So we do need the practice on that part. All right, guys, that's it for today, and we will see you back in class.